Hey guys, Mr. Backerberg here. In this video, we're going to look at lenses, tangents, and normal lines. So in the law that describes how light changes direction as it enters a lens, the important angles are the angles that the light makes with the line that's perpendicular to the surface of the lens at the point of entry. Now this line is called the normal to the surface at the point of entry, and the normal is a line that's perpendicular to the tangent of the profile of the curve at the point of entry. So in this example, we're going to look at finding a tangent line and a normal line to an ellipse. So we're going to find the tangent and normal line to the ellipse given by the equation x squared minus xy plus y squared equals 7, specifically at the point -1, 2. So the first thing we're going to have to do is some implicit differentiation. So we're going to take the derivative of this whole equation, starting with the x squared. So if we differentiate that, we get 2x minus, now when we look at this xy, there's really multiplication happening in there. So we're going to have to think about it like the product rule. So the x is our u value, and the y is our v value. So what we've got in here is we're supposed to leave the u thing alone, but then take the derivative of the v thing. So if we're differentiating that y, we just get 1, but because we differentiated a y term, we have to attach the dy dx from the implicit differentiation. And then if we do the rest of the product rule, we're supposed to keep the v thing the same, and then differentiate the u thing. So if we differentiate the x, we just get 1. And then we've got to differentiate this y squared, so we're going to use the power rule there. So the 2 drops down as a multiplier on the y, but then that's a y term, so we have to attach the dy dx. And then on the right-hand side, when we derive that 7, we just get 0. Now inside of our parentheses, if we work on cleaning up that product rule, x times 1 is just x with the dy dx attached. And then on the end, y times 1 is just y. And then we've got plus 2y dy dx equals 0. I'm going to distribute this negative in here. So then this is going to say 2x minus x dy dx minus y plus that 2y dy dx equals 0. Now, when we've got this implicit differentiation, we're trying to solve to get dy dx alone. So what I'm going to do is move everything that doesn't have dy dx in it over to the other side. So I'm going to move this y over to the other side by adding y over, and I'm going to move this 2x over by subtracting the 2x. So now on the left-hand side, we've got negative x dy dx plus 2y dy dx equals y minus 2x. Now because both of our terms on the left-hand side have that dy dx in them, we're going to factor that out. So this is going to say dy dx times negative x plus 2y equals y minus 2x. And then to get the dy dx alone, I'm going to divide this set of parentheses over to the right-hand side. So this is going to say dy dx is equal to y minus 2x over negative x plus 2y. So this is the derivative from doing all of that implicit differentiation. But we're not done, because we were asked to look specifically at the point -1, 2. So now we're going to take that x and that y and plug them into this derivative where they need to go. So then this is going to say 2 minus 2 times -1 over negative 1 plus 2 times 2. On top, -2 times -1 turns into positive 2. So the top is just 2 plus 2. On bottom, this double negative in the front turns positive. 2 times 2 is 4. So we get 5 in the denominator, 4 in the numerator. So we've got that 4/5 as our slope. But we're only partway there. We did the derivative, we found the value of the slope, but now we need to write out our equations. So first we're going to do the tangent through that point -1, 2. So if we do some point slope stuff, to get our tangent line, we would have to do y minus 2 equals that 4/5 slope times x minus negative 1, so plus 1. Working on cleaning that up, I'm going to distribute the 4/5 in there. So this is going to say y minus 2 equals 4/5 x plus 4/5. I'm going to add that 2 over to the 4/5. Now when we do that, we're going to have to get common denominators. So 2 is really like 10/5. So I'm going to get y equals 4/5 x plus 14/5. So that's our tangent line. But then we also wanted to do the normal line. So the normal line uses the perpendicular slope in our point slope form. So this is going to go y minus 2 equals negative 5/4 times x plus 1. Distribute that negative 5/4 in. So y minus 2 equals negative 5/4 x minus 5/4. We're going to have to add that 2 over to the right-hand side. But again, we'll want to get common denominators in there. So 2 is really like 8/4. So we're going to get the equation y equals negative 5/4 x plus 3/4 as our normal line. That's going to be it for this video. Thanks for watching.